And now we are going to quickly bring in Lauren and Cesar.
Another Coop Crash alum, yay!
They are from StackGen, happens to be the shirt I'm wearing. And they are here to talk about a really long title, how to maintain consistent and standardized cloud native infrastructure. Whew, wonder who wrote that. Okay, over to you two.
Amazing. Hey, everyone. We're excited to be here today to talk to y'all. First, we're going to introduce ourselves, though.
Hello, everyone. I am Cesar Rodriguez. I am VP of Engineering at StackGen. And before StackGen, I was a security architect in the financial industry where I learned the growing pains of early public cloud migrations. And I embarrassingly thought you would implement cloud standards similarly to the way it was done on-prem through spreadsheets and operational procedures until I learned how to codify and use tools like IAC and Terraform to help with this problem. And then I complained to people like Lauren when it wasn't scalable.
Indeed. And as Cesar said, I'm Lauren. I'm the VP of Product here at StackGen, but I used to work at HashiCorp on Terraform. So I've spoken to a lot of people who both love and hate infrastructure as code, sometimes at the same time, which is completely fair because there's a lot to love and a lot that can stress you out about infrastructure as code. And if infrastructure as code has ever made you groan a bit, you are not alone. We recently ran a survey coming out soon about infrastructure as code, and we found some interesting things. Like 97% of users report having difficulties with infrastructure as code. And only 13% of organizations report that they achieved IAC maturity. And that kind of makes sense when you consider that 98% of respondents said they believe their organizations need more IAC expertise. And that's a lot of speed bumps on the way to the infrastructure as code highway.
But well, how do we achieve full value with IAC then?
It's a very excellent question, Cesar. I'm so glad you asked. I think for us to really get the full value of infrastructure as code, we need it to be three things. First, streamlined. So deployment of infrastructure, whether that's for an app or upgrading your architecture, is aligned with all of the teams that are involved, so everybody has a better and more productive experience. That more productive experience accelerates our time to market, our ability to meet consumer demands, and just kind of improve everybody's day overall, right? Because we don't have unnecessary conflict and frustration while we all try to figure out what everybody needs and wants in order to get something out the door. Streamlining does require us to automate so that everyone can deploy regardless of their expertise with infrastructure or infrastructure as code. Second thing we need is for our infrastructure as code to be standardized so that all the guardrails to help it be consistent and secure and in line with our policies are present. This helps us keep our infrastructure and deployments secure, keeps our security teams happy, which we all love happy security teams. To do this, we need governance so standards are applied, ideally at the time of IAC creation, and even more ideally, automated so that we don't have to remember every applicable policy every single time. And third, to get the full value of IAC, we need it to be created aware of the context in which it's being created for. The best infrastructure as code is written tightly scoped to its originating purpose, whether that's to deploy a consumer app into the world or to update the version of a database. Contextual awareness helps keep us and our infrastructure as code productive by keeping dependencies scoped, right? That builds more resilient and reliable infrastructure, and it helps create alignment between the teams that, it requires creating alignment between the teams that need the infrastructure as code and the teams that are creating and managing it. Also something that automation can help us with. But let's talk a little bit about what that means in practice.
So here's some options of solving IAC challenges. One of the common way we implement standards is through the use of something called golden templates. And in this approach, you would have a collection of cookie cutter IAC templates or modules that can be used in generic use cases across your team or organization that have been battle tested, hardened, and contain your guardrails by default. This approach can save time. It gives your development teams a step up in the right direction, but it creates a bottleneck on your cloud experts maintaining these templates, adding new features and capabilities, and new template support for new technologies. You can also try to get teams to adopt IAC SDKs and CDKs or language-based tools to write ISC in the language and format that they're most familiar with. And this has the benefit of being easier to adopt for developers because it works in a toolset or language they already know. Downside is that they still need to know what infrastructure they need for their app or project to be successful and how to properly configure it. The last option is infrastructure from code. In this approach, instead of using generic templates as the baseline to your cloud infrastructure, you'll use your business and application requirements as codified into your source code and configuration and infer the infrastructure requirements for your applications from there. What does it mean?
Good question. Infrastructure from code uses an application as the starting point. So figuring out what infrastructure is required to successfully run the app and generating the infrastructure as code needed to fit the needs of that app. But because it's coming from the app code first, infrastructure from code will always create least privileged and minimum viable infrastructure from the start without requiring an individual human to know what permissions need to be set or what resources to provision and in what order. And there are several different ways you can use it.
So the SDK approach of IFC is where you explicitly embed the infrastructure requirements and cloud resource management directly into your application source code. For example, if you need a cloud resource like a DynamoDB table in AWS, you would use the SDK to define the resource that you need and declare its configuration within your code itself, within your application code.
Exactly. You can also pick up an infrastructure from code programming language where you write your application or other thing from the start in a language built to generate infrastructure once your project or app is complete. This can be a bit of a heavier lift for some folks, though. You'd need to learn a new language and then write your app or project in it, and that may or may not be possible depending on the rules at your company.
Then the last approach is using static code analysis to infer your infrastructure requirements from your existing application code. With static code analysis, the application code will scan along with configuration files to determine what are the dependencies that the application has in terms of resource requirements and cloud APIs. And this information is used then to create a cloud environment that is tailored specifically for what the application needs. This approach doesn't require modifying the application code and requires less overhead from a developer perspective. This is the approach that we recommend at StackGen that you do follow.
And to go a little bit into detail on what static analysis gives you, static analysis, as it says in the name, analyzes your code base, right? To see what its structure, API calls, etc., indicate that it needs in order to be deployed. But then it should give you something to review, maybe a visual topology or some kind of architecture list so that you can see what infrastructure is going to be created and fix it if it's not exactly what you need. And then static analysis approaches should generate your IAC for you from that diagram or architecture list so that you can get it into your deployment pipelines. But let's talk a little bit, where does that fit into your workflow?
When using static code analysis for IFC, your current workflow doesn't change. Your code and artifacts live in the same SCM where they've always been, GitHub, GitLab, etc. If the IFC tool will then pick it up from there and use the information gathered to create your IC, whether it's Terraform or Helm charts, and then your existing release process kicks in, where you can use an IC lifecycle management tool to provision your infrastructure or a workflow management tool, and a CD tool such as ArgoCD to deploy your application into your cloud environment.
Amazing. How about you show us how that could work in real life, Cesar?
Sure. Let me share my screen. All right, for this demo, I'm going to use an open source repo that we forked called Dodge API. This is a Python-based Flask repository that very simple application that we're using for demo purposes. I'm going to be using StackGen as the static code analysis tool to generate my infrastructure from the source code. So first, I'm going to log in with my GitHub account. Then I'm going to create a new app stack from source code. I'll click here. Before the demo, I pre-configured this particular repository to be available within the system. So I'll search for it. API. I'll click proceed. And here's where we can tell the static code analyzer where my source code is and which location within the repo, and if I had multiple services within the same repo. In the case of .api, we have a single service. It is located in the root path. It's a Python-based service. And for this demo, I'm using this branch called demo ArgoCD. So I'll click proceed. Then for my target compute environment, I'll be selecting AWS EKS. And the view that I'm showing is the developer workflow. But my admin here has configured some policies that are applied by default as part of the generation process. So what this means is that if there's any particular governance, control, or guardrail that you want implemented, it's just included as part of the generated IC files. And I'll show you what that means in a few minutes. So let me click proceed. I'm going to name this .api, and then I'll hit create. And once I hit create, this is where the static code analyzer clones the repository. It performs static code analysis, and then it uses the information from the repo to infer the topology architecture of what the system will look like once it's provisioned into a cloud environment. So we'll give it a minute, and then we'll see what it looks like. This is a very simple application, so it should be quick. So the process is done. One of the things that it's asking me is it detected that I rely on a Postgres SQL database, and it's asking me if I want it within the cluster itself, or if I want to use a managed service like RDS in the case of AWS. So I'll pick RDS for now. And then I'll modify this workload with some of the required fields here for my image. And let me pull that up where I'm publishing this Docker container, Docker image, I mean. The image tag that I'll be using is latest. And then something else that I picked up is the environment variables that this application need. I'll populate this with some values. And there we go. I've saved this information, and everything that you're seeing here from a topology perspective is backed by the policies that we picked, and is also backed by the Terraform and Helm charts under the hood that are being generated for provisioning this infrastructure and deploying the application. So I'm going to make some changes here. Let's say that I'm a developer. I initially thought that I needed RDS, but I want to change and pick a NoSQL database because I want to have less overhead of a relational database within my code base. So I can pick DynamoDB connected to my workload, which will give it access. And it's as simple as that. I can modify some of these settings if I choose to in terms of how my DynamoDB table is configured. Let's say that instead of having the billing mode provision, I want to have pay per request. And here, what I'm getting is an error message. It's telling me that I am not in compliance with one of my policies here. And if I try to export this by pushing to Git or downloading my IC via zip file, it doesn't let me because it wants me to fix this issue that we've set up for my organization, where I need to make sure that my billing mode for DynamoDB tables needs to be provisioned to avoid unpredictable surges in cost. So let me go ahead and fix that. And let me click save. And now let me click push to Git if I'm ready to go with this with this infrastructure as code generated. I'll click push to Git. I've pre-configured this with my forked repository here. And now the system will create a pull request with my IC into the repo. So let's see what that looks like. Okay, so as you can see here, it updated with the Helm chart. It updated with the module for DynamoDB, the IAM role that I'm using to access that DynamoDB table, and a policy as well. I have a GitHub action workflow configured to this repository where it's doing Terraform plan for any new pull request. So I can see that as part of this change, the system will be creating an IAM role, the policy, and the DynamoDB table within this workflow directly. So since I'm good with this, I'll go ahead and merge the pull request. I'll delete this branch. And I've also pre-configured here ArgoCD. So the way ArgoCD works is it will sync with the latest changes within my repository, pick them up, it will sync them into my cluster. Here you see I have a failure error from my last run when I was preparing for this demo. But if I refresh, ArgoCD will sync the latest changes. Now it's trying to provision any new changes in terms of the pods that I'm creating and the new Helm chart that I'm creating and provisioning that into my Kubernetes cluster. At the same time, if we go back to my GitHub workflows, since I merged my PR here, I have another GitHub action which does Terraform apply. It's around 40 seconds ago. And once it executes, it's just a regular TF workflow where it's doing TF apply and creating the infrastructure components that I needed for my Dutch API application. All right, that's it.
Amazing. Thanks so much for joining us, everyone. If you want to try us out, go to stackgen.com, where you can also look at our white paper if you love a good white paper. If you have questions or comments, email us at info@stackgen.com. We love hearing from you. And Cesar, I think there's a question in the chat for you.